You can't do that. If you know that the test statistic is negative 4.92, that's in different places on different curves. Because do you remember how the t-curve changes depending on your sample size? You might remember this, you do remember this. You start to come back. As the sample size changes, the bell curve that is the t-distribution either gets flatter or gets taller depending on. The larger it gets, the taller it gets, and the more it looks like a normal curve. And the smaller the sample size gets, the more it flattens out. So that becomes the problem. We'll just stop talking about it right now. The problem is I can't get a p-value from that easily. I have to use a t-table, and even if I use the t-table, there's nobody's promising me that I can actually find this number on it. That's where technology is your friend. Technology is your friend. Let's go to it. Let's go to it now. You don't have to do that. Sweet Jesus, no. You don't have to do that.
So a quick question
yes.
along that line. So on that, when we're doing the proportion curve, that one doesn't squeeze in?
No. That one, when we change sample sizes, the central limit theorem says all curves get tighter. But the thing is, even not using the central limit theorem, the t-distribution changes with sample size. Even before you make it inferential, when it's still descriptive, it changes. And that's one of the funkinesses about the t-distribution, and I don't want you to get hung up on that. That's why we're using technology to do it. Yeah, I don't want you to, if you can forget, I'll make a list of things you can forget that for the score. It's just totally fine. Alan?
I'm just curious, you can't make any real conclusions from that -4, can you?
Hang on, not yet. Not until the p-value to go with it.
Okay.
That's the whole point. We're kind of stuck right now. We're kind of stuck because if the sample size is small enough, that in and of itself could, theoretically, not mean anything if the sample size is very small, although it's hard to believe that it would be insignificant, being almost 5 standard deviations away. All right, you ready? Let's play. Let's play. So we need a new menu. So let's grab our TIs. Stat tests. Now, up till now, we were using that guy, that number 5, the 1 prop Z. We can't use him anymore. I mean, if you go to him, you're going to realize that nothing looks correct. So we have to use a t-test. And guess what? He's number 2 right there at the very top. T-test. Boom. T-test. Yes. T-test. So what you're going to do is, you're going to get in there, and you're going to input your new data. So we have data. Sometimes if you have studies, you're actually given summary statistics. For example, this study might have come back and said, we had 61 trial patients. They had an average of 94 IQ points, and they had a standard deviation of 9.3 IQ points. You can actually put, if you go to statistics, you can see that you can input, there they are right there. They actually call themselves in, which is kind of sick. I try whatever I can to get you guys raw data, though. It's better that way, I think. So go with data. Mu naught, what do you think's going to go in there, based on how you know 1 prop Z in, or Z test works? Your null value. In this case, it is 100. In this case, it's 100. Yes, perfect. 100. Where's your data? Mine's in L1 and L2, I believe. Mine's in L1 and L2.
Oh, if I did mine backwards, do I do...
L2, L1. Yes, ma'am. And I want to check, now that I said that, I'm going to check mine and make sure mine's actually there. It is. Yeah, wherever your data is, make sure that's in the thing that says list. And then just grab the correct sign. In this case, less than. Yes, we're testing to see if it's lowered it. And your choice to calculate or draw, although I think most of you are going with draw, it seems like that gives us the 2 things we need. So let's go ahead and do that. Draw it. Oh, crap, hang on. I was just going to say, make sure all your plots are turned off so you don't get an error. Rule.
Why did it draw so slow?
Because it's a t-distribution. Because this is a hell of a workout for it.
Oh.
Yeah, this is a hell of a workout for the TI. The t-distribution is no pushover. Compared to the z-curve is a very, very easy. But this bad boy has got some iteratives. Does that t-statistic look familiar? Negative 4.923. That sounds like the one we came up with before when we did it. I kind of did it by hand real quick for you. And that's great. The problem, as Alan pointed out, is that doesn't tell us anything because it doesn't tell us where it lives on the curve. Well, now we know it's so far down that the p-value rounds to 0. It's not actually 0, it just rounds to 0. It's so far down this way. Remember our concern about a type 2 error? it's starting to look like our data is actually heading down towards that other curve, and this is kind of a quantifiable measure of that. Oh, yes. Here we go. Let's come back over to here. Okay, so now the question is, we have that test statistic that we were looking for. Remember, the whole point was we needed to know where it lives up on this curve. Well, we now know. It lives at negative 4.9 and some change. Negative 4.9 what? Negative 4.9 what? Standard deviations from 0. That's significant. Shelby, ask me that question.
How is that the same
How is it the same?
as the number we got before? Because wasn't it not the standard deviation?
No.
So we got that.
It's standard error, standard deviation. Look, this guy right up here. That right there.
Right, but that didn't mean anything.
Without the p-value, you have to interpret what it means with the p. That's what the p-value comes
Is it
in.
always the same, or is it because our sample size is above like 30 or something?
Oh, very good. Can I come back to that question? Because if we drop that bad boy down, actually, you know, let's do it right now. Let's do it right now. Shelby asked the question, a very good one. Suppose, oops, what if our sample size was only 30 instead of 61, but we had the exact same results? So I'm gonna do some finagling, that's a great question. What if it was 30 instead of 61, but we had the exact same, arguably 94 plus or minus 9? Let it draw it for us. Watch the two numbers that come up. Watch the values that come up. It takes a while, it's kind of... Notice. See what just happened? It's less extreme. We picked up more p-value. It's still significant by a 95% confidence, but it's less significant. So the reason is, even though the curve looks like it's close to 100, because so many people showed that slightly less than 100, it becomes statistically significant. Alan, you're talking about practical significance. I can't measure that. Because you might say, we've statistically shown that a drop of 6 percentage points with this margin of error is statistically significant, to which you say, what do I care about that? That's 6 points on a scale that's centered at 100. And that's when I say, okay, you're saying the same thing I'm saying. I'm saying I've measured mathematically there's a statistically significant difference. And you've said that there's no practical difference. That doesn't mean we're both right or both wrong, or one's right and one's wrong. We both could be right about that. Yes, there is a statistically significant difference, but it might not mean anything. But that's where this class cuts off. This class shows you how to measure the statistical significance. And you go to your next classes and measure the practical significance. Does that make sense, Shelby? I hope I've answered your question. I hope. If I haven't, we'll go back. I think I have. Maybe I haven't. And as that sample size drops, it'll get less and less significant to the point that it's not significant anymore. If you have a sample, say 4 or 5 or 6, it won't be significant anymore. That's why your next project next week shows you how to deal with exceedingly small and oddly shaped distributions. Good. Die. Well, let's finish this and then we'll come back to that question. Let's get through, because we're almost done, aren't we? We've got ourselves a test statistic and a p-value. Let's make a conclusion. You don't know, that's okay. I forget how to make conclusions, that's okay. It appears or does not appear? Hell yeah, it does.